All right, y'all. So the next topic in our math review is our trigonometric functions, sine, cosine, and tangent. There, I briefly thought about deleting this and going back and starting over, but no, I'm going to force through. Sine, cosine, and tangent. So if you've got a TI-83 calculator, which let's see here. That's fantastic. There we go. Sine, cosine, and tangent are basically right there in the middle. And then above the sine, cosine, and tangent, you see the inverse of those functions. And how do we get to the inverse of those functions? Well, we choose the second button right there. But sine, cosine, and tangent are useful if we have a right triangle. This will only work if we've got a right triangle. So a triangle with a 90-degree angle there. And if we know something about two of the three sides, or one side and an angle, and I guess that's it. Okay, so let's call this angle right here theta. The side that's right next to that angle is what we call the adjacent side. And some of you guys, I can hear you maybe saying, well, you know, there's another side that's right next to that angle. Well, yeah, it is, but that side is the hypotenuse of our right triangle. Okay, so that's the hypotenuse. The shorter side is the adjacent that's next to the angle theta is our adjacent side, and then this side over here is opposite because it's opposite the angle. All right, so there are a set of formulas that we can actually use with sine, cosine, and tangent to figure out an unknown if we know two of those four different items that I've got up there. All right. There's a little mnemonic that we can use to remember our three formulas that I'm going to show you guys. It's SOHCAHTOA. So literally SOHCAHTOA, SOHCAHTOA. All right, well, how does that work? Well, so that'd be sine and then opposite and then hypotenuse. Cosine, ca is cosine adjacent on hypotenuse. And tangent is, or excuse me, TOA is tangent opposite and adjacent. And so if we can remember that mnemonic, then we can also remember these formulas here. So sine of theta would be equal to opposite over hypotenuse, and so on and so forth for the other two formulas. All right, and again, this says it's only valid for right triangles. All right, so let's check out maybe an example of how we might apply these formulas. So let's say that we've got a right triangle. And let's call this angle theta here. And let's say that we know that this side right here is a length of 5.0. And this side right here is the one that we want to know, x. Okay, and also, let's say that we know that theta is 30 degrees. And so our question now is, what is x? Well, we think through what we've got. We've got the angle theta. We've got the number for the side that is adjacent to theta. And what do we actually want to know? We want to know the side that's opposite of theta. So let's see, we've got theta. We want to know the opposite, and we've got the adjacent. So if I think back to those formulas, which one's going to apply? Well, let's see. I've got the angle theta. I've got the adjacent. But what is it that I want to know? I want to know the opposite side. So it seems like the formula I should use is the bottom one there with tangent. All right. So let's see here. Let's apply that. Tangent of theta, and theta is 30 degrees, is equal to opposite over adjacent. All right. So I want to isolate x. So how do I do that? I multiply both sides by 5 because 5 is in the denominator over there. So if I multiply through by 5, I will have 5 times the tangent of 30 degrees is equal to x. Oops, that disappeared. So, and if I stick this into a calculator, if I pull out my calculator and stick in tangent of 30 degrees and hit the enter button, it's going to return the value about 0.577. And if I multiply that value that's on my calculator screen by 5, I get 2.89. And that's my value for x there. And if I'm going to be picky about significant figures, I should probably just write 2.9. I'm honestly not all that picky about significant figures for the most part in this class. You know, that said, we do go over it in the first chapter. All right, so let's look at another example. So maybe same kind of idea. I've got a triangle, right angle, my angle theta. And let's say that I know that this side right there is 5, and I want to know what this one is. And again, I'm just going to pick something easy. Let's say that theta is equal to 30 degrees. Well, let's label what these sides are again. So in this case, my side that's length 5 is opposite theta, and my x is adjacent to theta. So I've got theta. I'm interested in opposite and adjacent. It seems like I should use the same formula that I did on the previous slide, which is exactly right. Tangent of theta is equal to opposite over adjacent. All right, let's stick in our values. Tangent of 30 degrees is equal to opposite, that's 5.0 over adjacent x. Okay, now I've got a bit of an issue, and this is a kind of a trap that we can fall into, is how do we deal with x when it's in the denominator? Well, I want to get it out of the denominator. How do I do that? Well, I multiply both sides by x, both sides of my equation by x. Okay. When I do that, on the left-hand side, I end up with x times the tangent of 30 degrees. And on the right-hand side, I end up with just 5. Well, that's great, but I want to isolate x. And I've got tangent of 30 multiplying x. So how do I get rid of that? Well, I just divide both sides by tangent of 30. And that's going to give me x is equal to 5.0 over the tangent of 30 degrees. Tangent of 30 is about 0.577. If I divide 5 by 0.577, I get out the value 8.66. And again, if I'm going to be picky about sig figs, I should probably just write that as 8.7. All right. So there's that one. Maybe let's look at another one. Let's look at the case where, use your imagination, that's supposed to be a right triangle, where this is 5 and this is 3, and I don't know what that angle down there is. Okay. So I'm looking for that angle with the question mark. I want to know, in this case, well, what is theta? Okay. And let's label our sides again so that we kind of understand exactly what we've got. We've got the hypotenuse, and we've got the we've got the, whoops, and that right there is why there's an eraser in this program. There we go. Pretty cool. Pen, okay. The side that's labeled 3 is the opposite side. Okay. So let's see, I want to know that angle theta, and I've got opposite and hypotenuse. So I think through my mnemonic. So, ka, to, okay. Opposite and hypotenuse. That means that I should use this one. Sine of theta is equal to opposite over hypotenuse. Okay. Well, so let's go ahead and plug in values. Sine of theta is equal to 3 over 5. Oh, so let's see, 3 divided by 5, that's 0.6. So it looks like sine of theta is equal to 0.6. Well, how do I get that theta out of there? Well, to get the theta out of there, I kind of do a little mathematical trick. I do the inverse operation on both sides. Well, let's see. What's the inverse sine of sine theta? That would just be theta. Okay. So on the left-hand side, I'm left with theta because I've done exactly the opposite of sine. And then on the right-hand side, I've got sine -1 of 0.6. So at this point, on your TI-83s, you would hit second and then sine to get to that inverse sine. Then you would enter 0.6, and then you would hit the enter button to get your answer out. But the answer ends up being 36.9 degrees. There we go. And I could quibble about sig figs again, but yeah, I think this is okay for an example problem. Maybe I should have listed my side links as 3.00 and 5.00. All right, I think that, well, let me maybe do one more. And of course, if you get the point, feel free to stop watching. Nobody's checking. So let's say that, switch things up just a little bit. There's my right triangle. Let's call this angle up here theta. And let's say that theta is equal to 70 degrees. And let's say that I want to know what this side is there. And I know that that side right there is 10.0. All right. So I've switched things up a little bit. I've been sticking with theta being the angle in the lower left of the triangle. Now it's the angle up at the top. So we have to think about what x is. Is that the side that's adjacent to theta or opposite theta? Well, for the theta that we're working with, this is the adjacent side. Okay, and that side that's horizontal would be the opposite. And of course, the hypotenuse is the hypotenuse. All right, I think through my mnemonic again. I know theta, I know the hypotenuse, I want to know adjacent. So, ka, toa. Seems like cosine of theta is equal to adjacent over hypotenuse. Because I have the angle theta, I've got the hypotenuse, I want to know the adjacent. Cosine of 70 degrees is equal to x over 10.0. Multiply through by 10. I get x is equal to 10 times cosine of 70 degrees. And when I plug that into my calculator, I should get out the result that x is equal to 3.4. 3.42, I guess, because I gave us, well, I guess 2 sig figs there, 3 sig figs there. Maybe I should have left it as 3.4. 3.4 what? I don't know. I didn't say whether we work in meters or inches or whatever. So we're just 3.4. One more thing, maybe I should have mentioned a bit earlier. Make sure your calculator is in degrees mode instead of radians mode. That's a little tricky, especially if you have reset your calculator for some reason. Say you were taking a test, make sure you put it back in degrees. All right, that does it for this one.